This is from the 1970s, from 75. It was a Telequipment D66A twin trace analog scope, 25 megahertz, in really quite nice condition, a bit dusty, and I understand from the previous owner hasn't had a lot of use. He gave this to me because he's clearing out his workshop. He used to do TV repairs and was not interested in any of the test equipment anymore because he's moved on. There aren't any TV repairs anymore anyway. So he said, was I interested in this old Telequipment D66A? And I said, well, yes, I'd be interested in, if nothing more, to make a video. And my first oscilloscope I owned was a D62A. I'm sure it was a D62. I'll have to check that. And that was an all-valve scope. This is a semiconductor scope, obviously from the 70s, and it looks in pretty good nick actually. There's no horrible scratches or dings, and it's dusty, but it hasn't been powered on for 10-15 years. So we're going to give it a power up this evening and power it up on the Variac just to see, make sure it's not drawing too much current, and give the caps a chance to reform. It's quite nice actually because it's got a couple of interesting features. Not only has it got the normal calibration output, which is 500 millivolts peak to peak, it's got a ramp and a square wave output, which is unusual. It's got the single shot mode and repetition mode, which is basically normal or single sweep on a digital scope. It's got basically basic trigger controls, high frequency reject, TV line, AC/DC, automatic, so it's, in theory, I assume it's the same as the automatic on the digital scope. Plus or minus, triggering on the plus or minus edge of the scope, internal or external triggering. This is our time-based control here. Got a nice feel to it, and a variable time base, and the click for the calibration. It's a horizontal position, and there's our fine adjustment for horizontal. We've got our trigger level here. We've got focus and intensity. We've got scale illumination and trace rotate, which is nice to have those on the front panel. Stigmatism adjustment here, that gives you the correct focus to give you a center, so your dot's in a nice fine defined dot rather than like a rugby ball shape. Amplifiers here, volts per division up to 50 volts per division, down to 10 millivolts. Same thing, fine calibration here. I don't know if there's a I don't know which is fully clockwise is cal. It doesn't click, but you just wind it fully clockwise. There's your position here and here, and you got, looks like an invert button here on this, only on channel 2, so this is your invert, and chop on alternate. So basically on chop, what the beam does, it goes, when it's scanning, it goes from the first trace to the second trace and just alternates it. And at low time-based speeds, it looks like you've just got a jittery display, but they look like they're running continuously. If you run in alternate mode at low frequency, you get that one, then you get that one, then you get that one, and then you get that one. And the alternate mode works better at higher time base. And I'll try and demonstrate this as this scope works. I'm not very good at explaining stuff like that. So I've done a quick check. The plug looks okay, the mains lead looks fine. What I'm going to do is do the normal procedure. I'm going to start one of these scopes up in reduced power. I'm going to set my Variac to 40%. I'm going to power it up. I'm just keeping an eye on the current. We just saw it surged and then dropped back, so the current consumption is normal. I don't even know where the power switch is on this. These are buttons here to turn the various channels on and off. Obviously, because I'm on reduced power, I'm not expecting to see anything yet, but I will turn the intensity fully up. And I think the outer control is focus. And what we'll do is we'll give it a couple of minutes just to give the caps a bit of a chance to reform. But I think the power switch from memory was one of these. Oh, there's the power switch. Okay, so we've got full scale illumination. Nothing showing at the moment, but there was a slight surge in current, so we're hoping that it's probably working okay. So what I'm going to do is wait for a minute, and then we'll just increase the voltage slightly. But we just need to give these caps, if they've been sitting around for a while, just a bit of a chance to reform. So let's increase it to 150 volts, 160 volts. I can see an increase in current. There's no sign of any lights on the front. Ah, there we go. You can see there, very dim dot in the centre there. Okay, so that's good. Let's try focus control. Focus control's working. Intensity, it pulls it down, but it looks like that's okay. And we've got 2 beams there. Oh, there we go. So that's 160 volts, and straight away we've got a dot. So that's good. So let's increase it to 200 volts. And what you don't want to do is burn the screen, but we're not scanning at the moment, so let's go trigger mode. It should be in free running. AC auto, internal trigger. Channel 1 is on, 2 is on. So we've got the first signs of, there's obviously the HT is working on the CRT, and it looks like that's some fairly bright screen already. So just see if we can get the focus adjustment any better. There we go, that's astigmatism correction. But it's not sweeping, so let's try and get the sweep to work. So horizontal position, yeah, that's working okay. Not very noisy pots. Okay, let's increase it, turn the brightness down. Let's get some sweep here. Why are we not sweeping? Trigger mode. No. So we should be sweeping now. Internal trigger, channel 1, channel. Just see if we can get the second channel up. Should be. Channel 2, there we go. There we go, that's channel 2. But we're still not getting any sweep, which could be a problem with the... Oh, okay, so fully anti-clockwise on that control there actually puts you in XY mode. Okay, so we've got a trace. There we go. Let's increase it to 240 volts. See, I tell you, it's pretty bright actually. Horizontal position. That's good. And we've got a really nice bright trace. Focus adjustment. Astig. So that's looking really quite good actually. So I suppose the next thing to do is connect it up to possibly function generator and see if the scope actually produces any viable waveforms. So I'm going to connect it up to the Philips signal generator. I'm going to put a 1 kilohertz square wave in. Let's see if we get anything. So channel 1. Dirty switches. Move channel 2 out of the way for the minute. Time base. And now we've got to try and work out how to trigger it. So where are we? Trigger stability. It's this one, is it? This brings back memories of trying to get these bloody things to trigger properly. So let's do DC triggering. Positive slope. We should be on internal triggering. Okay, triggering is very, very twitchy on this. Let's increase the time base. Make sure just checking to make sure the function generator isn't sweeping, because it probably would really struggle with that. Okay, so we're struggling with getting it to trigger. We've got variable time base. Okay, so we can get the trigger. See, it's stationary there, but trigger circuit's not working particularly well. What other trigger options we've got? Let's try auto AC and see what that does. Auto AC doesn't work. Button in for internal. That's why. Looks now like the triggering's working perfectly. So it looks like to me that that's working pretty well. So let's just try. That's good. So I suppose the next thing to do is check to see how accurate it is, but I mean initial power up looks like this scope's working pretty well. I think what we'll do next is we'll take the thing apart. I notice there's a bit of disturbance in the waveform, possibly something like a 50 Hz modulation, so it could be that a couple of the caps are failing, but at present it looks pretty good. You've got nice defined imagery on the screen. Probably need to adjust the focus and things like that, but we can come back to that. But it's pretty nice display, as you can see there. So what I'll do next is I'll pop the side off, and we'll have a look inside and see what the state is inside. Another interesting thing with this scope is I've noticed that the line regulation is pretty poor. If you notice, I'm at 250 volts. The scope's, I've set the tapping on the scope to 250 volts. If I drop it to 240, you see the shift in the display. Let me just zoom in so you can see. It's almost like a voltage regulator's not working very well. So this is 130. The display gets a lot dimmer, which you'd expect. 250. But you can see the display moving about, and that's just with voltage change. Let's get those both in the same display at the same time, so you can see what I'm doing with the voltage. But you see that's sort of like making a significant difference on sweep speed and amplitude as well. I don't know if that's just the way these scopes work. It could be that, that's what you expect from a scope of this age, and probably isn't very well regulated. But let's take the side off and have a look and see what we've got. Okay, it's the inside, and as you can see it's pretty dusty, but it's got a couple of capacitors, as you can see. The power supply electrolytics made by Pi, and they've got a date code as 375, so that's obviously March 75. That dates the scope to 42 years old or so. More than that, isn't it? 45, coming on, yeah, 40 years old. So the internals look pretty good actually, a bit dusty, there's no sign of any burning, and the chap suggested it hadn't had an awful lot of use, and looks pretty clean to me. See, it's got the transistors in the socket here. I don't know, zoom in and you can have a look at that. But the socketed transistors here, you can see pots here for adjustments of various things. Let's have a look down here. We've got the this is the time-based switch here with its trimming capacitors and things down here. All that's going to need cleaning. Got a switch here for the what switch does this? What does this do? It looks like. Oh, look at that! The whole mechanism moves. That's a bit clunky. No idea what that does. What does that do? Doesn't say what that does. It might be a times 10 mag sort of thing, but it's all very, it's all very sticky and vague. It looks like the whole thing needs cleaning and lubricating, but we'll get back to that. But it doesn't actually say on the front panel when it does. Oh, it does, but I can't read it. It says push XY or fully anti-clockwise X only. So okay, so that's XY mode when you push it. So it activates the switch on the top here, and obviously activates the XY mode. So it's in nice condition. It's going to obviously need a full calibration. I think the thing to do is power it up, which is actually powered up now, so don't stick your hands there, Simon. But it's powered up at the moment, and keep an eye on these capacitors to see if any of them are getting warm, and then maybe do a few checks and download a service manual for it. But I suppose the first port of call is to go through the switches and pots and clean all the contacts up before we start twiddling around with it, because there's no point in setting it all up if the pots are all dirty. Let's turn it around to the other side. And these are the vertical amplifiers here for channel 1 and channel 2, and you can see basically they're like almost like a stereo pair, mimics either side. And there's your RF amplifier attenuators this side. It's the HD cap for the CRT, and I see that the cathode ray tube looks like it's made in Staplehurst in Kent by Magnetic. Oh, that actually might be just the Magnetic Shielding. Magnetic Shielding Limited, Headcorn Road, Staplehurst, Kent, which isn't a million miles from here. This is knocking, jarring or distorting will destroy the special magnetic properties of this shield. I imagine it's some sort of mu metal, but I can't be sure of that. If you look here, you can see that this is the deflection part of the circuitry here. This is your probably your vertical deflection for X and Y. Basically, that's one of the electrodes in the gun. Rather than using electromagnetic deflection like it does in a TV, it's using electrostatic deflection. So basically, you increase the potential in this point here, and that will pull the electron beam up, so you get your vertical tracing here. But it's all in pretty nice nick, and I think the next thing to do, as I say, is probably clean all the dust out of it, clean the pots up, and then see if we can perform a calibration.